Hi guys, welcome back to another exciting day of math. Sorry, I couldn't say that with a straight face. Today we are going to talk about factoring. So pretty much throughout the next set of videos, we're going to be talking about one thing and one thing only, factoring. So the directions are going to read factor, direction number 2, factor, fun problem number 3, factor. Okay, so factor is going to be like your new favorite F word, trust me. Okay. But in order for us to talk about factoring, we have to talk about greatest common factor. So let's go ahead and do this. Now, what is the greatest common factor? So the greatest common factor, I love those words because the words themselves is a definition. So the greatest common factor for two or more numbers is the biggest factor that they have in common. So let's just say quick, what's the greatest common factor between say 16 and 12? So I'm like, okay, GCF of 16 and 12. What is the biggest factor that these numbers have in common? Or in English, what's the biggest number that goes into 16 and 12? So the biggest number that goes into 16 and 12 is 4. Okay, 4 is the largest factor common to 16 and 12. That's nice. What if I say, quick, what's the greatest common factor between 8 and 9? So in English, I'm like, okay, what's the biggest number that goes into 18? What's the biggest number that goes into 8 and 9? I'm like, nothing. Okay. When it appears that the numbers don't have any factors in common, then the GCF is 1. Okay, because 1 is a factor of everything. Okay, so let's go ahead and knock out fun problem number 1. So the directions read, find the GCF for the list of terms, and for some weird reason, we're given the light to just list the answer. We're given the green light to just give the answer without work attached. So if you can answer mentally, then go for it. Okay, so we have two problems. Let me go ahead and write the first problem. So I want to know what is the biggest factor between, what is the greatest common factor between 80 and 100? If you're like, I'm a genius, I think it's 10, then go for it. But to tell you the truth, I'm not quite sure if 10 is the greatest common factor. I know it's a factor, but I'm not sure if it's the biggest. So what I'm going to do, I'm going to show some work. So we're going to do problem A 2 times. The first time around, we are going to use the ladder method. Okay. Well, how does that work? So I'm going to explain the technique as we do the solution. Okay, so again, if you can answer mentally, then go for it. We're given the green light to just spit out the answer because it says if you can answer mentally, then go for it. But if we don't have that disclaimer, then you need to show me some work. Okay, to find the GCF by using the ladder, we're just going to write our numbers going across. And then we're going to do the ladder. So like the ladder is like this, but that just looks like it's floating in the air. So we're going to do the ground. So yeah, that's my made up story. So pretty much the ladder method, you put the numbers across and then you do the upside down into symbol. The into symbol is like this, but when you flip it over, it's upside down. So I just call it the upside down into symbol. How does the ladder method work? So the ladder method, once you prep it up, since this is pretty much an upside down into symbol, we're going to divide. Okay, what should we divide by? You know what? I need you to divide by the first number that comes to mind. If you need to do 2 like 50 times, then go for it. The smaller the factor, the more steps you'll have. The larger the factor, the fewer steps that you will have. But to tell you the truth, as long as you start dividing now and not like 10 minutes later, you'll finish sooner than later. Okay, for me, this is how I see it. Both of the numbers end in 0, so let's go ahead divide by 10. Okay, 10 goes into 80 8 times. 10 goes into 100 10 times. I should know that. How can we tell when we're done? You're going to keep on dividing until your leftovers don't have any more factors in common other than 1. So in this case, 8 and 10, we can divide by 2. So let's go ahead, bust out another ladder and divide by 2. 2 goes into 8 4 times, and 2 goes into 10 5 times. 4 and 5 have no more factors in common other than 1. So we're going to stop right here, which is great. Now the question is, where is the ladder? So I'm going to type, where's the ladder? Where's the GCF? The GCF is given by the product of all the numbers to the left of the ladder. So we're just going to multiply 10 and 2. So we have GCF is given by the product of all the numbers to the left of the ladder, namely 10 and 2, and that will give us 20. Okay, so the moral of this story, the biggest factor common to 80 and 100 is 20, or fancy words, GCF is 20. So let's go ahead and do this problem one more time. So again, we call it A2 because we want to highlight that it's the same problem, but then again. So what if you don't like the ladder method? I don't know why you wouldn't, but whatever, people are weird. So we're going to go ahead find the GCF, but this time around, we're going to find the GCF by using prime factors. Okay, so let's do this. So if we're going to find the GCF by using prime factors, the first thing that we need to do is write each number as a product of prime factors. To facilitate the process, we're going to go ahead and use factor trees. Okay, so we have 80 and then we branch it out however we like. So I'm going to just do 10 times 8. Okay, we cannot read each other's mind, so our trees may look different, but if we keep our cool, all the tips, should match. Okay, 10 is the same as 2 times 5, and I like to circle the prime numbers because sometimes we have so much board work that I tend to lose the prime numbers. 8, we branch it out, it's 4 times 2, where 2 is prime, and then 4 is 2 times 2. Okay, so let's go ahead, branch out the 100, and then we'll summarize our results. Then we'll write each number as a product of prime factors. So we have 100. There's different ways to write it. I'll go with 10 times 10. We branch out the 10. That'll be 2 times 5. We branch out the other 10. That is 2 times 5. Okay, so I need a break, like a real one, but I need a visual break. So let's go ahead and write 80 as a product of prime factors. So we have 80 equals, and it will be nice if we write the factors in order from smallest to largest. So we have 2 times 2 times 2 times 2. I believe that was 4 of them. So we have 80 is the same as 2 to the 4th power. Okay, do you have to cross them out? Absolutely not. Okay, I choose to cross them out because it kind of highlights that we already put it in our multiplication list. And then we have to multiply this by 5. Okay, so if you think you maybe messed up over here, like you have it like if you had an arithmetic mistake, just punch it in. 2 to the 4th times 5, that should give you 80, but I trust you. Okay, so let's do this. 100, when we write this as a product of prime factors, we have 2 times 2, that will give us 2 squared, and then times 5 times 5, okay, or 5 squared. Now let's not forget, we are trying to find the greatest common factor. So at this point, to find the GCF, we are going to multiply the common factors. So multiply the common factors. Sorry, I have a habit of putting uppercase letters where they don't belong. Okay, so the toughest part about finding the GCF by using prime factors is to successfully write each number as a product of prime factors. Once you've done that, you're good. Okay, so let's go ahead and multiply the common factor. So we have GCF equals. So I'm going to ask myself, what factors do like 80 and 100 have? Okay, so 80 and 100 both have some 2's in common. The question is, how many 2's do they have in common? 80 has 4 factors of 2. Yeah, that's not nice. Okay, so 80 has 4 factors of 2. 100 has 2 factors of 2. So the question is, how many 2's do they have in common? It's only going to be 2. Okay, let's go ahead and write down the 2 squared. Okay, now what else do the numbers have in common? So both 80 and 100 have some 5's, but the question is, how many 5's do they have in common? 80 has 1 factor of 5. 100 has 2 factors of 5. So overall, how many factors of 5 do they have in common? Just 1. Okay, so we're going to multiply that by 1 factor of 5. Okay, I guess I could just say use the smaller exponent. So once we simplified, we already know what the answer is. Okay, once we simplify, we should find out or confirm that the GCF is 20. The square of 2 is, what is the square of 2? 4. And then the product of 4 and 5 is 20. Okay, So cool. So no matter how we do it, whether we do straight answer or we use the ladder or we use prime factors, we should get the same answer. How do I want you to do it on the test? I'm very consistent. Whatever I write for notes, that's how I will write the wording for your test. Okay. So yeah, in this case, if you can answer mentally, then go for it. Okay. So we're gonna do 2 problems for round 1. We did the first one. Let's go ahead and do the second one. Do I have space? Let's just pretend like we do. Okay. So problem B, the terms that we're gonna consider, where am I? We have 180 times a squared times b to the 5th times c cubed, and the second term is 300 times a to the 9th times b to the 4th times c to the 5th. Oh, this is in my way. That's what I get for trying to save a paper. Okay, so remember guys, pause and rewind as many times need be. Okay, so let's do this. So I want to know, what is the greatest common factor between both of these terms? For the variable factors, it's a little bit easier for me to identify the GCF. Like both of these terms have an A. How many A's do they have in common? Similar for B's and C's. Okay, what it's really messing with my flow right now is for the integer factors. Okay, like 180 and 300. What is the greatest common factor? I really don't know. I don't think it's just 10. Okay, so I'm gonna do some work. Are we gonna do this problem twice? Of course not. We're gonna do it once. If you can answer mentally, then go for it. But I'm gonna go ahead, show some work, and I'm gonna go ahead, use the ladder. Okay, so I'm gonna write down only the coefficients. Can you write down the variable parts? Yeah, but you know what? The less I write, the less confused that I will be. But if you need the variable parts, then go for it. Okay, so again, the ladder, we put our numbers across or in a horizontal format, and then we'll do the ladder or the upside down into symbol, and we are going to divide by the first thing that comes to mind. Same speech, they both end in 0, so for me the first thing that I see is 10. So let's do this. Let's go ahead, show the reader what we're left with when we divide both of the numbers by 10. 10 goes into 180 18 times. 10 goes into 330 times. Fantastic. And we're going to continue to divide until we can't. So 18 and 30, you know, there's lots of things that we can divide by. Like 2, 3, I don't know. Like what's the number that comes to your mind? 6? Alright, let's go ahead, do 6. So if we choose to divide by 6, 6 goes into 18 3 times, and 6 goes into 35 times. So remember, we're going to continue to divide until our leftovers don't have any more factors in common other than 1. 3 and 5 have no more factors in common other than 1, so we're good. So the GCF, where are you? The GCF is given by the product of all the numbers to the left of the ladder. So in this case, you know, it's 60. Let me go ahead, write it over here. All right, fantastic. The original terms that we were given were not 180 and 300. You know, we had those variable terms. So I need a pause. Cool. Let me go ahead and write the problem over. So we have 180 a squared b to the 5th c cubed, and 300 a to the 9th b to the 4th c to the 5th. Fantastic. Okay, so let's do this. Sorry, I'm running out of space. Okay, let's go ahead and do this. What is the GCF between these two terms? Well, for the coefficients, thanks to your hard work, we know that the GCF is 60. Okay, that's what we got before. But we want to know, what else do the terms have in common? So let's do this. Both of these terms have some A's in common. How many A's do they have in common? The first term has 2 factors of A. The second term has 9 factors of A. So overall, they only have 2 A's in common. Okay, so again, we have to use the smaller exponent. It's not because teacher said so. It's just we can't say like, oh yeah, they have 9 A's in common. That's a lie, because this one doesn't have enough to get to 9. So we use the smaller exponent. Okay, what other variable factors do they have in common? Both terms have some b's, but the question is, how many b's do they have in common? The first term has 5 factors of b. The second term has 4 factors of b. So overall, they only have 4 factors of b in common. So let's go ahead and put that in our multiplication list. Okay. So like for the variable factors, you kind of treat them like the prime numbers. You're gonna multiply the common factors. Okay. Where am I? C's. Okay, they both have some C's. How many C's do they have in common? The first term has 3 factors of C. The second term has 5 factors of C. So overall, they only have 3 factors of C in common. Let's go ahead and add that to our multiplication list. So thanks to your hard work, with confidence, we will tell the world that the greatest common factor is given by 60 a squared b to the 4th c cubed. So we're going to do a total of 3 different sets of problems. This is set 1. Let's go ahead and do set 2. Okay. So set number 2, the directions read, where am I? Factor out the greatest common factor. Okay. So that's how it's pretty much written in most of our books. And in semi-English, it says divide the GCF from the expression, whatever that means. Okay. So let's go ahead and rewrite the first problem. We have negative 44 x to the 8th y to the 7th z minus 110 x to the 6th y to the 10th z squared. Okay. So it says factor out the factor out the greatest common factor. Okay. In order for me to factor out the greatest common factor, whatever that means, it would be nice if we identify the greatest common factor. Okay, so let me just put GCF equals. So I'm like, okay, well, what is the greatest common factor between the terms, namely 44 and change and 110 and change? I'm not quite sure, so I'm going to go ahead and bust out a ladder. Where should I do it? I'll do it right here. Okay, so the coefficients, I'll do it right here, because I'm not going to write down the variables. Okay, so the coefficients, yeah, I'm having technical difficulties. Okay, so the coefficients of the terms are 44 and 110, and we're going to divide by the first number that comes to mind if we use the ladder. So I'm going to go ahead and use 11 with your permission. 11 goes into 44 exactly 4 times. 11 goes into 110 exactly 10 times. We can continue to divide, so let's go ahead and write another ladder. 4 and 10 have a common factor of 2. So let's go ahead, pull it out, and show the reader what we're left with. 2 goes into 4 2 times, and 2 goes into 10 5 times. 2 and 5 have no more factors in common other than 1, so we're good. So the GCF is given by the product of all the numbers to the GCF is given by the product of all the numbers to the left of the ladder. So in this case, it's 22. Okay. So the GCF, I don't have space. Maybe I should have written it below. Okay, so the GCF is given by 22. What else do the terms have in common? So the terms have some x's in common. It's going to be 6 of them. How many y's? 7 y's, 10 y's. There'll be 7 y's. How about some z's? 1 z, 2 z, so only 1 z in common. Okay, so the GCF is given by 22 x to the 6th y to the 7th z. Okay, so it says factor out the greatest common factor. So pretty much we're gonna take this and divide it from the expression. So we're gonna write 22 x to the 6th y to the 7th z. Okay, let's go ahead, put an open parentheses, and then we'll show the reader what we're left with. Now, I want to point out that our first term is negative. So if we factor out a positive 22 and change, negative something divided by positive something divided by positive something will give us negative something. Okay, that's too many words, so I'm going to just say it a little bit different. When you take out a common factor, it would be nice if the first term you're left with is positive. Who cares if the rest is negative? But it would be nice if we started on a positive note. So what we're going to do to start on a positive note, we're going to go ahead factor a negative 22 x to the 6th y to the 7th. Cool. Now let's show the reader what we're left with. first term divided by the common factor, I know you're on it, but if you want to show like a thinking area, then go for it. Okay, so this is what's going on. We're going to take the first term. Where am I? First term. And divide it by the GCF, which is negative 22 x to the 6 y to the 7z. And then we're going to simplify. So negative 22 goes into negative 44 exactly 2 times. Quotient of the x's will leave us with x squared. Quotient of the y's, they cancel out. And the quotient of the z's, they cancel out. Okay, so that will leave us with 2x squared. Okay, so pretty much this is the behind the scenes. If you don't need this, then I don't need this. Okay, so the GCF, when GCF goes into the first term, exactly 2x squared times. Okay, but me saying like that doesn't really work for me. I say it the other way around. First term divided by GCF will give us 2x squared. Second term divided by GCF, you can show the work or we'll just do it right now. Negative 110 divided by negative 22, punch it in, and that will give us 5. Quotient of the x's, x to the 6 divided by x to the 6 will give us 1, or we say it cancels. Quotient of the y's, y to the 10th divided by y to the 7th will give us y to the 3rd. Quotient of the z, z squared divided by z, 2 minus exponent of 1 is 1. So that will leave us with z. Okay, so the direction said factor out the greatest common factor. So we identified the greatest common factor, and then we factored it or divided it from the expression. What do we do? Nothing. That's it. Okay, we factored it from the expression. So that was nice. Okay, one problem down, one more to go. Okay, problem B, we have 3x plus 2 times x minus 4, and we're going to subtract from it 3x plus 2 times x plus 8. Okay, fantastic. Now, we are trained to clear grouping symbols, so I really want to like FOIL out the first 2 binomials and FOIL out the next 2 binomials. But I'm going to go against my normal train of thought. I want to point out that the products have a common binomial factor of 3x plus 2. So in this case, our greatest common factor is going to be that binomial. So I'm going to say GCF is given by 3x plus 2. Okay, so sometimes our GCF is just one term, or sometimes our GCF may be a binomial. It is what it is. Okay, once we have identified the GCF, we're going to factor it or divide it from our expression. So we're going to write 3x plus 2 times whatever we're left with. So let's do this. First product divided by GCF, 3x plus 2 divided by 3x plus 2, they're going to cancel out, and that will leave us with x minus 4. Okay, if this is not working for you, let's go ahead and do a thinking area. Okay, so I'll write out the problem again. Okay, so this is pretty much going to be the behind the scenes. We'll write out the problem again. Okay, so again, we want to factor out the GCF from the expression. First product divided by GCF. The 3x plus 2's cancel, and that will leave us with x minus 4. So again, you can show me your thought process, or you can go straight to the answer. Let's do this. Next product divided by GCF. The 3x plus 2's cancel, and that will leave us with x plus 8. But let's not forget to bring down the minus sign. Okay, so again, next product divided by GCF, the 3x plus 2's cancel, and that will leave us with x plus 8. But check it out, we have to be very careful. This subtraction sign will affect the value of the terms of anything that follows it. So the way it's written, we're only subtracting the x, not the entire thing that we're left with, or not the entire x plus 8. So let's go ahead and wrap it up. Okay, so if you're cool with this, cool, we move on. And if not, you're like, no, I want to show my thought process. Then show yourself your thought process, and that will leave us with minus x plus 8. Again, do what you got to do. Okay, so we're done with the factoring. So let's go ahead, close it up. And I know what we're trying to tell the world. We're trying to tell the world, hey, this is what happens. This is what we're left with when we factor out the GCF. We're left with GCF times our leftovers. But check it out. The world does not read this as GCF times our leftovers. The only thing that's being multiplied by our leftovers, the way I have it on paper, is just 2. Not the entire 3x plus 2. So we're going to have to wrap it up. Okay? How come we didn't wrap up the GCF before? Well, that's just because our GCF was just a single term, not like more than one term. Okay, so be careful. Let's go ahead, clean up our leftovers. Okay, so we have 3x plus 2, open parenthesis, x minus 4. Let's go ahead, distribute the negative, at the opposite. Okay, opposite of a positive term is a negative term. Opposite of adding 8 is subtracting 8. So let's go ahead and do this. So when we clean it up and combine the like terms, x minus itself will give us 0, what we say cancels out. And then the sum of the constants, negative 4 minus 8, will give us negative 12. Okay, we factored out the GCF, we cleaned up the cleaned up our leftovers. This is our answer. The question is, why don't we distribute the negative 12? If you distribute the negative 12, you're no longer going to have an expression in factored form. So just leave it as such. If you're not going to be able to sleep tonight because the integer factor is not in the beginning, then go ahead, rewrite it. So optional, you can rewrite as negative 12 times 3x plus 2. Okay, so fantastic. So again, which one will make me happy? They both will make me happy. Okay, cool. So that is the end of that. Okay, so we're gonna do a total of 3 sets of problems. 3 sets of problems. That was round 2. Let's go ahead, wrap it up with round 3. Okay, round 3. So okay, I love this problem because there are different ways to factor polynomials. Depending on the polynomial that's given, that will determine the factoring strategy that we will use. Today, we are going to factor polynomials by factoring. We have a lot of directions, but I'd rather read them to you as we move along. Okay, so let's go ahead, knock out these 3 problems, and then we're done for the day. Okay. So problem A, we have 2wx minus 2wa plus x minus a. Okay, so the question that I'm going to ask myself is this: okay, what strategy are we going to use to factor? Well, I should read the directions, but sometimes I get so excited that I forget to read the directions. So the directions read factor completely. So what does it mean to factor? If you're being asked to factor, that is code for write me as a multiplication problem. Okay, no multiplication problem here. Let's do this. What strategy are we going to use to factor? The strategy that we're going to use is based on how the polynomial looks like. How many terms do we have? If we have 4 terms, how are we going to factor it? By grouping. Okay, so to factor a 4-term polynomial, by grouping. So how many terms do we have? 4. How are we going to factor it? By grouping. All right. How does this work? So we're going to group the first 2 terms, group the last 2 terms, and then take it from there. Okay. So step number 1, make your groups of 2. Group your first 2, group the last 2, and then factor out the GCF from each group. Okay. So from the first group, what is the greatest common factor? 2wx and 2wa have some things in common. They have a 2 in common. How about the w's? Yeah, they have a w in common. How about the x's? No, and a's? No. Okay, so thanks to your hard work, the GCF for the first group is 2w. Now let's go ahead, factor it from the group. First term divided by GCF, 2wx divided by 2w will give you x. Second term divided by GCF, that will give us negative something. 2's cancel, W's cancel, and that'll leave us with A. Cool. So one group down, one more group to go. How do we factor a 4-term polynomial by grouping? Make teams of 2 and then take out the GCF from each group. For the second group, so I'm like, okay, what's the GCF? And I'm like, oh man, X and A, they don't have any factors in common aside from 1. So if the GCF is 1, then 1 it is. Okay, so we have a plus sign. Let's go ahead and put plus. And I feel a little bit silly, but that's the procedure. Write down the GCF and then factor from the group. First term divided by GCF, surprise, still X. Second term divided by GCF will give us negative A. Now, if this is a nice problem, then the binomial factor should match. Okay, so I'm trying to look for my other highlighter. Okay. Looking for us, the binomial factors match. It's not always the case, but we'll take this gift. What are we going to do right here? Same thing that we did before. Okay, so I'm going to go ahead and put out the earlier problem. So for problem B, in the earlier problem, the GCF was a binomial. We identify it and factor it from the expression. Okay. So let's go ahead and factor out the GCF of X minus A. And then we'll show the reader what we're left with. First product divided by GCF. The X minus A's cancel, and that will leave us with 2W. Second product over GCF. The X minus A's cancel, and that will leave us with plus 1. Okay, I never wrote down what I have, sorry. First product divided by GCF, that will leave us with 2W. I thought I was giving like a verbal solution, sorry. Second product over GCF, the X minus A's cancel, and that will leave us with plus 1. Okay, so the directions read factor completely, factor being key. So factor is code for write me as a multiplication problem. But the completely part is, did you break me down all the way? So this is how we do it. Did I really factor all the way? Let's see. X and A, they don't have any factors in common other than 1, so we're good. 2W and 1, they don't have any factors in common other than 1. So we factored all the way or completely. Let's go ahead and do this. So we have a total of 3 problems for this round. Let's go ahead and do the next 2 and then we're done for the day. Okay, problem B. We have 8 m squared n squared plus 40 m squared minus 12 m squared n cubed minus 60 m squared n. Okay, fantastic. So we are asked to factor or factor completely. So the first question that I'm going to ask myself is this: how many terms do we have? We have a total of 1, 2, 3, 4 terms. So I'm like, okay, how do we factor a 4-term polynomial? Oh, if we have 4 terms, we factor it by grouping. Okay, cool. How do we factor by grouping? Okay, let's go ahead and make our groups. We're going to group the first 2 terms, group the last 2 terms, and then take out the GCF from each group. For the first group, the GCF, I'll look at the factors one at a time. 8 and 40 have a common factor of 8. What about the variable factors? We have m squared, so we have both m's in common. Let's factor it out. And then what about the, that's it, no n squared. Okay, so the GCF for the first group is just 8m squared. And let's show the reader what we're left with when we factored from the first group. First term divided by GCF, the 8's cancel, the m squareds cancel, and that will leave us just with n squared. Second term over GCF, 40 divided by 8 is 5. And m squared divided by itself, cancels out. Cool. One group down, one more to go. 12 and 60, what is the greatest common factor? I think it's 12, okay? And if not, we'll see right now, okay? 12 and 60 have a common factor of 12. For the variable factors, both terms have 2 m's in common. For the n's, the first term has 3 n's, the second term has 1 n, so overall they just have 1 n in common. And I said it before, when you take out a GCF, it's to your advantage if the first term you're left with is positive. Who cares if the rest of the terms are negative? But it's important that the first term is positive. Why? Because things will line up nicely like that. Okay, so instead of factoring out a positive 12, we're going to go ahead factor out a negative 12. Okay, so the GCF, we're going to factor out a negative 12 m squared n. Let's do this. First term divided by GCF, negative 12 divided by itself is 1. So we say it cancels. Quotient of the m's is 1, and quotient of the n's will leave us with n squared. So like one division down, one more to go. Second term divided by GCF, negative 60 divided by negative 12 will give us 5. Quotient of the m's is 1. Quotient of the n's is 1, so that's it. Okay, so if this is a nice problem, once we take out the GCF from each group, the binomial factors should match. If they don't match, it's not that you did something wrong, it's not a nice problem. So let's do this. So procedure, how do we factor a 4-term polynomial by grouping? 1, make your groups of 2. 2, take out the GCF from each group. And then 3, factor out the GCF from the expression. So let's go ahead, factor out the n squared plus 5, and then show the reader what we're left with after we factor it out. First product divided by GCF, the n squared plus 5's cancel, and that will leave us with 8m squared. Okay, do you have to highlight this? Of course not, but that's like my thought process. Second product over GCF, the n squares plus 5 cancel, and that will leave us with negative 12 minus m squared n. Okay, the directions read factor completely. We have factored. Again, what does it mean to factor? A factor is code for write me as a multiplication problem, and we do. The completely part is, did you break it down all the way? Maybe, maybe not. N squared and 5, they don't have any factors in common, so we're good. But look, I'm crying, okay, because 8m squared and 12m squared n, they do have some factors in common, okay. So although we did factor, we didn't factor all the way or completely. So let's do this. 8 and 12 have a common factor of 4. The terms have some m's in common, namely 2. And no n's in common. Okay, so the GCF for this binomial factor will be 4m squared, and it show the reader what we're left with when we factored from the binomial. First term over GCF will give us, where am I, 2. Second term over GCF will give us negative 3n. Cool? And then you can bring down the binomial factor. So the question is, did we factor all the way? We sure did. Okay, if you box this, I'll give you full credit. I'll probably give you the stink eye, okay, because it's not aesthetically pleasing. Okay, this is a lowercase m, looks like an uppercase m, but it would just be nicer if we had the integer factor and the variable factor in the beginning. Okay, so now the book may or may not read your mind. So if the book answer doesn't look quite like yours, don't panic. So pretty much we have a product of 1, 2, 3, 4 things. So when I'm going to be looking on the test, do you have a times 4, a times m squared, a times n squared plus 5, and a times 2 minus 3n? The order of these 4 factors does not matter because multiplication is commutative. Okay, so let's go ahead and knock out our third and final problem because I have to start making breakfast. Alright, problem C, where am I? I don't have it. Oh, I do have it. Okay, so we have xy minus 32 plus 8y minus 4x. Okay, so the directions, okay, they're going to be the directions that you're going to hear until the chapter is over. Factor completely. So I'm like, okay, how am I going to factor? How many terms do we have? We have 4 terms. Oh, how do I do it when I have 4 terms? Oh, by grouping. Okay, so we're going to factor by grouping. Let's make our groups. We're going to group the first 2, and then we're going to group the last 2 and take it from there. The first group, x, y, and 32, what does my office mate say? Dog breath. Okay, I need to be like him. All right. The first group, they don't have any terms in the GCF for the first group. They don't have any factors in common, so the GCF is 1. Am I having a moment? Yeah, I am. But look, the GCF was 1 before and we had no issues. Okay. When we factor out the 1, xy over 1 is still xy. Negative 32 over 1 is still negative 32. So one group down, one more group to go. GCF between second group, namely 8y and 4x, is 4, and that's it. Let's go ahead, factor out of 4. Okay, so when we factor out of 4, 8y over 4 will give us, where am I? 8y over 4 will give us 2y, and then negative 4x over 4 will give us negative 4x. So I said it before, if this is a nice problem, then the binomial factors should match. Did we mess up? Of course not. We know how to divide. But unfortunately, this is not a nice problem. Why not? Because the binomial factors don't match. Okay, now, the directions read factor completely. So factor, what does that mean? Write me as a multiplication problem. You're going to come across problems that are not factorable, meaning you're going to come across problems where it's not possible to write it as a multiplication problem. But what do they say? If at first you don't succeed, try again. Pretend I said that with enthusiasm. Okay, so this is how it's going to go down. If grouping the xy with the neighbor didn't work out, then we're going to have to group the xy with the term that we see thereafter, namely 8y. So I need a break. I don't want to delete this because I want this to be part of my thought process. So we have xy, and we're going to write the term thereafter. And then we're going to write down the negative 32 and the negative 4x. So we have negative 32 and then the negative 4x. Okay. So now, how many terms do we have? We still have 4. So we're going to factor by grouping. We're going to group the first 2, and then we're going to group the last 2, and then we'll take out the GCF from each one. From the first group, xy and 8y have a common factor. No coefficient. Xy, it's just y. When we factor out a y, that will leave us with xy divided by y is x. 8y divided by y, where am I? Will give us 8. Okay, I'm going to go ahead rewrite this second group. Why? Because you notice how we have an x right here. So I want the x to appear first. So we have minus 4x minus 32. I'm going to bring down the first part of this puzzle. Okay, how do we factor by grouping? We make our groups. We'll group the first 2, group the last 2, and then take out the GCF from each group. From the second group, I know that you know that 4x and 32 have a common factor of 4. But again, we're going to factor out a negative 4 to ensure that we start on a positive note. Negative 4x divided by negative 4 will give us x. Negative 32 divided by negative 4 will give us 8. And look, why am I smiling? I'm not going to show you my face. Why are we smiling? We are smiling because the binomial factors match. Okay, now that the binomial factors match, let's go ahead follow procedure. Let's go ahead factor the binomial factor. Okay, so we'll factor out the GCF of x plus 8 and then show the reader what we're left with. First product over GCF, the binomials cancel, and that will leave us with y. Second product over GCF, the binomials cancel, so that will leave us with minus 4. So we have factored. Again, what does it mean to factor? When you are asked to factor, that is code for write me as a multiplication problem, and we did. But the question is, did we factor all the way? X and 8, they don't have any factors in common other than 1, so we're good. Y and 4, they don't have any factors in common other than 1, so we're good. So the moral of this story is that we did factor all the way. Now, how do you check it? I forgot because I was so excited, okay? But to check it, you're just going to FOIL it back out. You're going to multiply it back out and then verify that you have the same 4-term expression. The terms may be in a different order after you FOIL it out, but you'll get the same 4 terms. Okay guys, so I had said that we were going to do 3 sets of problems. This was round 3, so we're good. Thanks.